Thank you. Thank you. Hello, my name is Genta Kondo. I'm from Tokyo, Japan. And as she introduced me, I'm making this hand for people who lost their original ones. It is called bionic hand. And this technology itself is not that new. A German company called Otterbuck commercialized such hands like almost 60 years ago. But it's still expensive, and I have some thoughts on its design. So I'm now making this open source 3D printable bionic hand. I'll first show you some demo. Okay. So here I have a sensor. It's just a pressure sensor. And I plug this thing into it. So it's just it. But people who lost their hand, they still have arm left. And most of the time, this arm is active. So they also can put the sensor around the arm and then, move their hand intuitively like this. So that's basically what I'm doing. I'll give a bit long introduction of myself because I think it's important to know why you're doing this. Like I studied this project from my instinct. There was intuition that I have to do this, but sometimes it's better to be conscious of why you're doing that. So it's all related to my personal history. So I was born in 1986. So I'm now age 30, and I was born left-handed. How many of you are left-handed? I guess about 6 or 7, but it's minority, right? So most people are right-handed, and the world is made for right-handed person most of the time. The first time I used scissors, I couldn't use functionally because the scissors is made for right hand. There's lots of subways in Japan, and there's a gates, of course, but the most of the time the receiver of IC card is on the right-hand side, so I have to go like this. So I felt I'm slightly a disabled person, and I feel like the world is not designed to me. So that's my first experience that relates to the project, I think. The second one is cultural difference, cultural gap. I lived in New York when I was 4 to 8 due to my dad's job. I don't know how many of you have been to US, but it's a country there's lots of race and lots of language, and so how I thought was to express myself, express what is my identity. That's the way to get into the community and have your certain position. So I was taught to express, show and tell what you are to the age of 8. But I came back to Japan when I was 9 year old, the third grade of elementary school. And Japan is such a homogeneous country. It's an island in the East Asia. So we kind of see a virtue in harmony. We're taught not to express too much, but to be quiet and see what's the atmosphere is. So it was totally different from the US and Japan. And back then I also had a struggle that what I thought until the age of 8 is not fit to this environment here in Japan. So I also felt the world is not designed for me that time. So I'm kind of disabled person back then too. And in teenage, I played basketball. I was a serious athlete of basketball, and basketball uses lots of hands. So I guess that's why I'm doing something with hands. So this kind altogether made me take my journey in the bionic hand. And I finally started studying bionic hand in University of Tokyo and also University of California, Berkeley for 1 year as exchange students. And after getting the master degree, I decided to get out from the academic track to learn about the wide world, and then started my career in a company called Sony, consumer electronics company in Japan. And then after 3.5 years, I decided to start my own company called IXI, and spend full of my time on this project. And I also joined the nonprofit organization called Mission Japan. Okay, so how I see the hand is also important because that defines the way you design it. Like there's lots of people recently trying to make better bionic hand, but the attitude toward this something is different from person to person. For me, hand is for expression. Of course, the hand is the important, part for to do the daily chores, like cooking or like doing the laundry. Like that is the common thing, and that's important. But like my focus is beyond that, area, because I cannot imagine myself not having hand and not able to be playing basketball again. That's not me. And I guess like everybody has at least one or two hobby. No matter what it is, sports or like musical instrument, any kind of hobby requires hand. Hand plays such a central role to express your imagination and creativity. Even playing video game requires hand to control Mario or things like that. So for me, hand is for expression, and I want people, even without a hand, to express more in real life. So let's study a bit about technology too. So first, please look closely how you actually are moving the hand. So when I try to close the hand, the first thing I do is imagine that I will close the hand. It happens in the brain first. The image of the posture emerges in the brain, and then the format is changed to the electrical stimuli, and that goes through the motor neuron, and then contracts the muscles inside your arm. There's like tons of muscles inside the arm, and finally the combination of those contraction pulls the finger joints, and that makes the hand close. So we're doing pretty easily, but like if you look closely, that's brain, nerve, muscle, and hand. And we also can do like dexterous things. So what about people who lost their hand or who doesn't have a hand from birth? They don't have hand, but they help the system until this point. They have brain, they have nerves, they have muscles, but they just don't have hand. So what bionic hand tries to do is to sense the signals artificially on the arm, and then converts it to the motions of artificial hand, robotic hand, like this, like just I showed you in the very beginning. This is the video from my college age. It was in engineering department, so my focus was more on technology side. And I tried to make the hand move faster, like this. He's an actual amputee he lost from factory accident. I'm placing some sensors on his residual arm, and he's actually controlling it. The next clip, the wrist is moving together. So I also try to add more degree of freedom. And I also try to make fingers move independently, like this. And fortunately, this project got accepted for one of the famous international conference in robotics field. But it was not practical. It was not for the amputee. This hand is not amputee hand. This is my original hand. And also I place as much sensor as I can. Like it comes all over the arm. Like I guess I placed 8 sensors. So it's kind of working, but it's not a stage that it actually works in the practical field. I did 1-year study at UC Berkeley, and I actually used a brain signal. It was like invasive way. I placed 200 electrodes inside the monkey's brain and tried to figure out how monkey are controlling the hand, because as long as I keep using this sensor on the surface, I felt that I will never be able to play piano. And this was the original data from the hand, the actual trajectory the monkey made. And this is the trajectory that is inferred from the brain signal. It, kind of looks similar, and this was also published in the journal by my professor there. But again, this is, not practical at the moment. It's only 8-dimensional in the horizontal plane. The real world is 3-dimensional, and it's not on the position. Like, you have to take care about, speed and stiffness and things like that. There's like so many parameters. So it was the end of my master course, and I felt like if I can stay on the academic field, but like I couldn't see this, research going to public. Like, I kind of felt like this won't help people who are actually suffering for a long time. So I decided to go to Sony because I thought a company like Sony has technology, but they also have a sense of designing and also like the cost, like how to make a business. So they have a balance among those three things: technology, design, and business. Sony used to develop a humanoid robot of this size. They didn't made it to actually sell it, but they did that until around 2005, and this was the TV commercial broadcasted in 2003. Back then, I was, I guess, high school student, and like I was amazed by this TV commercial. I thought like a robot is finally here. Like, we could actually interact with a robot. So I thought to make this bionic hand actually be used by users, I should go to Sony and learn like how they managed to do it. But I spent 3.5 years there, but like I still kind of like saw this boundary there. In college days, I was a researcher, and actual user was kind of subject for the papers. So I have to do the experiment to publish the papers. So, we knew each other. Like, I didn't feel myself not willing to help him, but like the first priority was, to have a academic course, things like that. But also as a company researcher, they were the customer at the same time. Like, we have to make a profit to support a million of employees in the organization. So even if the user said, I really want this product, but sometimes we have to quit the project because it was not it won't be successful in terms of business. So there was a barrier, and I started to think, is there any way that I can break the boundary or not? So I finally decided to start my own company called ICSI with 2 other members. I'm a software engineer personally, so I guess there's lots of guys who are interested in industrial design, but like I'm not the one who actually designed this. It was this guy called Tetsuya. He worked for Panasonic for 4 years. He did lots of design there. He studied design there. And the other guy is called Hiroshi. He's a mechanical engineer, also from Panasonic. So it was these 3 members: designer, software, mechanical. And we thankfully received several international awards. I can hand this booklets around. It is well designed by my other friends about ICSI, and I heard that there's some communication design students too, so maybe this will provide you some hint. So can you pass it by? Okay. So I started a company, my own company with these 3 members. The reason I named my company ICSI comes from 2 reasons. First, because we were 3 members, so I put 3 eyes. It looks like 3 men starting to do something. So that's first reason. The second reason is it's an abbreviation for 3 EX words. It's an example of exchangeable extremity. That's the concept of this project. I'm making this hand, but I don't. My goal is not to have every person using exactly this hand. Like this is just an example. I wanted to like provide more choices because the current status, they only have one choice from the company in Germany. So I put my focus on the name of the company. And I started to draw what kind of world I want to build. So here, the lady is holding an umbrella. This is the the physical function I want to make. It's not for playing a piano. For this project, I can like compromise and not to do so much, but like I saw that holding umbrella is at least important because if you have only one hand and if it's raining heavily, if you hold an umbrella, you could basically do nothing with no hand, right? So I want to provide at least the basic function as a physical functionality. And also I put several other keywords. Like first one is fashionable. I don't want people to look prosthetic hand just as a welfare device, but as a fashion item, so that teenage boy started interested in fashion can see prosthetic hand at the same level as cap or like bag or sneakers or like all those fashion items. Another keyword was 3D printer. I want to make this 3D printable, not just because it will reduce the cost, but because I thought 3D printing technology will let people to make the hand by themselves. So I dreamed that one day a girl missing left hand can make her original hand together with her mom, just like cooking a meal by downloading the recipe from the internet. So you can choose whatever design you want from the internet and put some, like, for example, heart mark to make it more personal. This is the idea I have on the 3D printing technology of the future. I also made it open source because I saw lots of elemental research could be add up. As a researcher in university, I attended several international conferences and I saw lots of cool technology. Like there was like great battery, there was great motors, but most of the time those technology was isolated and they hardly get integrated because it's so difficult for one lab to make the whole hand. They have to focus on one technology and like make it deeper and deeper progress. So I wanted to have this platform. This is not necessarily great in terms of technology, but it's integrated. So once I have this platform, perhaps people can keep add on their tiny progress on each element. So that's the idea for open source. And last but not least, I want to have this technology to apply to various fields. It's not only for prosthetic hand. And I guess that way technology itself also gonna evolve more. So for example, elderly lady who have weak leg but can still move their hand can have a same sensor on her and remotely control some robots, like cooker robots in the factory, things like that. So this is the image I had originally when I started my company. And I started to prototype the concept. I mostly made 3 versions. The first one was called Handy. And this was like concept prototype. It was for studying the potential of technologies and my idea. So I played with 3D printer a lot back then. It was around 2013. From this version to this black version, it only took like 3 months, I think. And each model, in terms of price, was less than 100 euros. We use Arduinos, all those inexpensive kit to prototype. And then I learned like 3D printing technology is really changing the world. Like it changed the way things are manufactured. Like in Sony, you had to spend tons of money to start making prototype because we were making a mold, or like we were carving the metals to make a prototype. So we have to plan in advance. We have to and estimate the risk first to actually start making things. But if you make use of 3D printer, the development method totally changed. Before thinking seriously, you could start actually making it and then review it, having that on the hand. So I learned that the new way of manufacturing might be coming from this project in Hackberry, Handy. And I submitted this prototype to several competition, design award, and also exhibition. And I started to be exposed on the media. And that connected me to the actual user, actual amputee. And then I started thinking that this hand, not only the tangible thing, but this should be applied to actual user. It should be controlled by actual user, and that will make this project more impactful. So I made Handy Coyote next. So this gentleman called Mr. Morikawa-san, lost his right hand by a factory accident in 2013. And this hand on left-hand side is the first hand he was prescribed by the doctor from the hospital. The physical function is same between those two. It only can open or close the hand, but the way it looks is totally different. Like conventionally, prosthetic hand was designed in this way to imitate actual skin, but it exactly isn't. And if you have this kind of design, it's hard for people around him to start talking about the hand. You kind of hesitate to ask him what happened. But once you have this kind of design, the design for fashion, aim for fashion, people will start paying attention and start talking and finally shake a hand and make a smile. It just happened no matter where you live, regardless of gender and ages. So I guess the fashion was I guess I proved that fashion is important factor for this. And then I started to develop the latest model called Hackberry because Coyote was really successful project, but it was only for demonstration. It was too fragile to let them use in daily life. The member of XE had to be next to him because it required repairment a lot, and also battery life was only 2 hours because it was only for demo. But to use in daily life, it had to be last long. So I made a Hackberry model as a practical one. Let me show another episode of another user. This lady is congenital case, which means she doesn't have her right hand from birth. And for congenital case, most of the time, they actually don't need prosthetic hand much because it is natural thing for her. She is grow up with only one hand and some joints in the other hand. So she could basically do any kind of chores in life. She can type keyboard on the average speed, so she can earn money by herself. So there was no reason for her to wear prosthetic hand, except this case that making a gesture at live performance. She's doing an indie singer in Japan, and apparently she can hold a microphone and sing beautifully. But she could not, make a gesture like waving hand and pointing the audience, which is also important part of live performance. So last year in summer, we provided her with one hand and made the first time for her to have a gesture in the live performance. And from this picture, I want to insist that it's really personal story that matters. Probably making a gesture is not important for every amputee, but for her, it's the only thing that matters. So if I take a hand as a our organ to express yourself, express personality, this have to be accomplished. The hand is not only for grabbing object in daily life. Let me show some technical part of Hackberry too.
これすごい。
嬉しいです。
嬉しいですね。
The current science technology doesn't let engineer to make the dexterous hand as it is. So we have to make a compromise and we have to focus on certain function. And for this Hackberry hand, we focused on pinching function because I thought it is important to be a supportive in many things like this. So he can now tie shoelace pretty naturally. And I brought some prototypes of Hackberry today because like the first model handy, also you make use of 3D printer a lot. And it was originally like this black model. So first we confirmed the mechanical design, like whether it works. So this is the index finger, and there's one actuator in the base joint. So it's gonna rotate as a like a stick, but when it hits the object, it changes its shape and like start to go around the object. So first we confirm this mechanism. And for other fingers, from middle finger to pinky, we saw it's not important to have like huge torque, so we designed it to move it synchronously. So we confirmed this mechanism too. So first we confirmed the mechanical design, and then we started to design the electronic parts and also the industrial design, how it looks. And after this model, we finally came up to the final version like this. Well, it is still updating, but I just want to show the way, the process we designed it. I can pass this to you if you want to take a look. Okay, right. So, and then, well, we have provided you the lady for singing, but then the next question was how could we provide to more people, and we were only 3 members. The resource was limited, so we came up with this idea to open source it, to have all the data available for free online, from 3D CAD data to the source code for Arduino inside, and also the bill of material, so that anybody who got interested in around the world can start 3D printing it and start buying the components required to assemble one hand. And not only the data, we also prepared this forum that people around the world can discuss, and we also have this schematics that make you easy to assemble it. So you need to buy these kind of components, but it's available around the world. You can buy most of the parts from Amazon or eBay, and you have to print out the parts like this. But like this altogether, you can assemble one hand like this. But first, we were kind of afraid that we were not confident who gonna make this out of ICSI, but it actually happened. So I guess 3 months later, we disclosed our data. This guy came to our office. He is an editor of newspaper in Japan, nationwide newspaper. And he himself is a congenital defense amputee. So he doesn't have his right hand from birth. But he got interested in this idea of open sourcing such a hand. And he didn't have any background in engineering, but like he started to actually build by himself with only one hand, doing soldering and assembling. And finally, he made one hand and posted on the top page of the newspaper like this. And it spread it out to the whole Japan, and like things started to spread out. The day after this issue came out, this elderly gentleman came to our office. He's saying that he lost his hand from World War II. I had met lots of amputees who cut off their hand by an accident or like by illness, like cancer. But it was my first time to meet a man who actually lost from a war. We didn't put address of our office on the newspaper on the article, but like he was so inspired and like he somehow managed to come to the office asking people around in the city to know the address of me. So like things like this happen in open source project, and now people are starting to recognize prosthetic hand as a fashion item. Like it's getting more casual, I'll say. So it's not only our company. There's like several companies, several organizations doing similar thing. A company called Open Bionics, based in UK, is also doing 3D-printable bionic hand, and they are collaborating with Disney. So they now have like Iron Man hand, or like Frozen hand, or like Star Wars hand, and kids love it. Also, non-profit organization called Enable, based in US, are making Captain America hand like this. And also ICSI is having customization. Do anybody know Metal, Baby Metal? Baby Metal is a J-pop artist, recent J-pop artist, girls band. It's getting popular and popular. Well, this is the Baby Metal version of our Hackberry, so it's Hack Metal. We didn't make it, but a professor from University of Yamagata, it's a rural university in rural area, but like this professor is big fan of Baby Metal, and he like just made this hand for fun. So I really like this atmosphere. Like you don't have to be like too serious about this kind of topic, and actual user also loves it to be treated more in casual manners. So, and our original Hackberry project is actually spreading around the world, from US to Europe to many parts of Asia, and VBionic team made this hand too. So let me show their video.
But troubles won't stay, they all just went away, and I ask 'cause I'm not sure, do problems even happen anymore? And I found a place where my mistakes are. I put a life there, a sacrifice for the good I could get in. Where I should, there a piece of advice that makes me happy, alright. My issues are done, my things all just get along, and they live in harmony, as if only to please me. And it feels right when it's late at night and my mind goes to sleep, and I feel calm.
So I really appreciate you too, the bionic team. And this project was really amazing because we originally only had this hand, which is adult size and right hand. But the bionic team made left hand and kid size version of Hackberry. It was reduced to 69%, that's around 70% in size. And now it's not only for adult, but like, you know, kids can also start trying it. So I really found the potential here of open sourcing project. Let me talk about the money a bit, because I guess that's also a concern of students who have a project. It was not pre-planned this way. It was really ad hoc process, but like I managed to raise some money somehow. So the first thing I did after I established my company was crowdfunding in Japan. There's a domestic service called Kibidango, and it was two months campaign, but I managed to raise 65,000 US dollars. What was more impressive was that 280 people with two hands, so intact supporters, actually gave us money to promote this project. So there's a way to get money, not only from the people who really need it, but like there's a way to include more supporters. Also, the competition was a huge push for us. Dyson, the company Dyson, making a vacuum cleaning company, and James Dyson actually is still alive. So this gentleman is Sir James Dyson himself. Nowadays, his company is so global, so big, so everybody knows about him. But he also had a struggle during his 20s, 30s, and it was in his 40s that Dyson vacuum cleaner actually was sold. So Dyson is supporting young entrepreneur every year and having a competition called James Dyson Award. And we won the second prize in 2013, receiving 15,000 US dollars. And back then we were still in Sony and Panasonic. It was kind of our hobby project. But since this award, we got to know with actual user and finally decided to start our own company. And after that, Dyson said we can sponsor you, and they actually are supporting us financially in 2015 and 2016. It was unofficial. There's no way to apply for sponsorship, but like people just helps us. And also Google gave us 250K US dollar as a grant. It was not toward ICSI Inc., the for-profit company I own, but it was toward a non-profit organization called Mission Japan. But I don't think it really don't matter which organization you can receive. But if you have many windows, there's like more chance that you can have a support. And ICSI is a company to develop this, and mission name is to disseminate, to inform more people. So this money is used to disseminate, promote to the world about this project. So since things like this happen, and like we somehow managed to survive for more than 2 years now. So what's the next step? This is the abstract schematic of how I vision the project. So, of course, the product is important, but as I said in the beginning, I see a hand as expressions. I want to see lots of personal stories. So, on top of this product, I want to build community first. One is open source community, and the other is local communities in each region. And on top of this community, I think lots of stories can emerge out, such as making a gesture at live performance, or things like that. So I want to make this, and to do that, I will start a lab called Agency Lab, because through my 2-year experience in this project, I found out that people are really subjective. Like people are too different from each other. So I define a word agency in this way. It's a like subjective fulfillment in the environment, and I want to focus on this humane topic and start some research. This is the first time we met Morikawa-san, who were shaking hand in the early movie. But he had a trouble. I mean, it took really long time to actually receive the bionic hand, even though he was eligible to receive one in the insurance system, because lots of doctors doesn't know there's such thing called bionic hand in the world, and also it's a minor case to lose a hand. So labor office in each local community doesn't know that insurance system exists. So he have to like search the information by himself. And it finally took two and a half years. I don't want to tell in the detail. But I guess if we have a community and share information, this could be reduced. And it actually happened. So this lady from Peru working in Japan had a severe car accident. She was crushed by a truck one day, and she unfortunately lost his right hand. But one day she came to our monthly meetup of NPO, and there was a Morikawa-san, and also there was a doctor. So she got information, and for her case, she received the hand in 2 months. So I kind of see the potential of community like this. Also, this is probably too technical, but I want to do research on post-cybernetics. Probably you know these kind of novels, like science fiction novels and movies and animation. But these all roots from this book called Cybernetics, which was published in 1950s. The important part is this subtitle, control and communication in the animal and the machine. So back in those ages, the animal was equally difficult as the machine. No, the machine was equally difficult as the animal. So, you know, we haven't reached the outer space yet. Like airplane crash more frequently than nowadays. So he tried to solve this problem in same frame between animal and the machine. And to make it really short, his idea was like this, to have a feedback loop. But I guess, you know, machines had a tremendous progress in 20th century, but I don't think animal should be treated in the same way. Like, it's not this simple that our brain moves our body. And this is a good example, I think. He's called Joe Davis. He's a bioartist affiliated with Harvard University. And there's one professor in MIT Media Lab, which is close to the Harvard, who himself is amputee of both legs, and for making really great bionic legs. And I asked him, like, do you want to use his leg because you live in close distance? But he said never, because it's not a thing he wanted. The leg he wanted is like this, like, you know, peg leg. So the way people think about leg, even though they have a like similar situation, it's different. But it was interesting that he said it's good to have the third arm probably. So. He was pretty drunk this time, but it's not like, you know, the same way that works. Like both Joe Davis and Hugh Hart, the Media Lab professor, doesn't have leg, but the way he wants to be treated, he want to behave, is totally different, like this.
Hello, welcome to TRS. I'm Bob Verdosi, CEO and President. Our mission is to provide you with the best possible prosthetic components for upper extremity that we can. In 1971, I was in a car accident, a car wreck that resulted in the amputation, crushing of my forearm and the amputation of my left hand. The Because of that incident, and because of my experimentation and dissatisfaction with existing technology in the early 1970s, TRS came into existence. Now, decades later, we still continue to manufacture and sell prosthetic components that are designed to allow you to have the best possible performance that you can have. Here at TRS, we focus on innovation, experimenting with new materials and designs that try to replicate human biomechanics so that we can produce products that provide you the best performance possible. We are the world leaders in producing and designing high-performance, voluntary closing prehensors and biomechanical hands, and especially the only company in the world that has dedicated itself to developing sports and recreational accessories. We want your input in what we do. If you're a prosthetist, a therapist, or other health professional, if you're an engineer, a student, a researcher, if you're missing your hand, we'd like to hear from you. TRS is a small, responsible company, and we're accessible and receptive to your ideas and to your input. I would be glad to be your personal resource in upper extremity prosthetic technology at no cost to you. The only thing you have to do is to reach out to us. I encourage you to check out our YouTube channel, which has a variety of offerings on it showing the vast array of products that we have in use by individuals here at TRS and by consumers all around the world. We encourage you to send us your YouTube videos so we can share your experiences, your history, your story with others. So thanks for watching. Keep a positive attitude. Lead by example. Take care.
So the guy for talking himself lost his hand by a traffic accident when he was in teenage. And I never met him, but I really like his approach because I think the hand doesn't have to be five-fingered, like as he showed in the video. Like it could be optimized to whatever you want to do in terms of sports and cooking meal, things like that. So this is just an example, and I think there's like variety of choices for prosthetic hand. How to design it is the most important thing. And last but not least, I want to also introduce that there's something called phantom pain. It's a pain that you experience after you lose your hand or leg. It's a brain confusion that brain has a body image, but like the visual feedback, the preparatory feedback you have after you lost your hand is different from that body image, and then you start to experience like severe pain every time randomly. So besides this prosthetic hand, phantom pain is another thing. As an engineer or designer, you have to deal with. The user is in the center, and yeah. Okay, so to wrap up the post-cybernetics part, I kind of feel the limit of cybernetics that takes biosignal as data and like body as media. Because unlike machines, human beings are like really subjective. Like every people thinks differently, and what they want to accomplish is also different. So I put agency as a key axis for the future study, and want to do scalable study from the neuroscience scale to the community scale. And this picture is what I want to accomplish with the Morikawa-san, who are shaking hand. He was a paraglider athlete before he lost his hand in 2013, but he haven't flight again after the accident. So someday in the near future, I want him to fly again, even cooler than before, and probably together with some kids suffering from physical diseases. So thank you for listening. This is the end of my presentation.
Cześć, jestem Bartek i powiem kilka słów, dlaczego ja również tu się pojawiam. Jest to kwestia właśnie open source'u tak naprawdę i od tego się zaczęło i o tym chciałem powiedzieć. Ja jestem inżynierem i hardware i software developerem, który był zmęczony programowaniem i chciał stworzyć coś, co ma fizyczny kształt i będzie obiektem. W tym samym czasie pomyślałem, że dobrze, żeby to było coś istotnego i zacząłem szukać, co na świecie się dzieje właśnie w tym temacie. W ten sposób trafiłem na EXI, które świeżo w zasadzie w tamtym czasie upublicznił swoją pracę i dzięki temu zacząłem pracować na bazie ich projektu. Udało się tą rękę zmniejszyć, to jest mój jakby wkład w ten projekt, poszukać też innych rozwiązań i cały czas gdzieś miałem w głowie to, żeby to się cały czas rozwijało. I właśnie fajne jest to, że w sumie rok temu nawiązała się jakaś współpraca między nami, facebookowa, tak naprawdę rozmawialiśmy sobie, konsultowaliśmy rzeczy, ja coś robiłem, Exit coś robiło i teraz możemy się tu dzisiaj spotkać. No i właśnie, gdzieś rozmawiamy o tym, co możemy zrobić dalej. I jakby w sumie chciałem zareklamować open source, bo gdyby nie to, no to ja bym musiał naprawdę dobry rok szukać kogoś, kto jest w stanie tak fajnie narysować rękę i to wszystko zrobić. Sam pewnie tego bym zrobić nie potrafił, bo to nie jest jakby moje pole, ale na tym właśnie myślę, jest to fajny przykład współpracy, która jest na polu takim technicznym, ale też tego dystansu, prawda? No Japonia jest dosyć daleko, wydawałoby się, że to jest trudne, a jednak się wydarza i jakoś zachęcić do robienia takich rzeczy, bo to możliwe. Pewnie jest pełno pytań, tak mam nadzieję. Ja też będę stał z boku, jeżeli byście mieli pytania takie, w których ja bym mógł wziąć udział też, bo jakby myślę, że jeśli chodzi o sam projekt też sporo wiem i może gdybyście mieli coś takiego, takie pytania w aspekcie, nie wiem, polskim, czy tego, co tu się w tym temacie dzieje. Bionic, w którym my z Marcinem założyliśmy Bionic, udało się sprawić, że mamy pieniądze na rok pracy. Znaleźliśmy inwestora, funkcjonujemy jako startup i w ciągu roku musimy zaprezentować nowe rozwiązanie. Taki jest, że tak powiem, deal. Więc będziemy również nad tym pracowali równolegle i dam teraz mikrofon, zapytajcie Gentę, będę z boku, gdybym mógł coś tu też jeszcze podpowiedzieć.
Genta, first of all, thank you very much for sharing your idea. And I just didn't catch watching video and while you said you focused in pinching. I mean, how many grips are enough to provide comfort to someone who lost his hand?
How many what? Sorry?
How many grips, pinching or grabbing, I think, is enough to just to take this function?
Well, it will never be enough if you compare with actual hand, I think. But I assume that most of the time amputees have at least one hand left, so they can do dexterous thing with this hand. So they also can tie shoelace by one hand, but it really takes time to do it by one hand, you can imagine, right? So I want this prosthetic hand to at least support it and reduce the time so that they don't hesitate to wear shoes with shoelace. So that's the idea. We designed Hackberry in terms of the functional or physical function. And I don't know, so it's only this movement. So like, I guess 60% of the volume here is used for the motor of index finger. So that's how it works. Yeah.
Okay, and may I also ask about adjustment of the hand to the residual limb? Does it need some customization or to each person?
Yeah, exactly. That's a good question. So this hand can be taken apart for the arm part and hand part like this. The hand part can be common, but this arm part, it has to be customized for each person because they have different size and different shape. And that's not a business of engineer. That's a business of prosthesis. There's a profession for our talented in customizing the shape of the socket, the part which connects the hand and the residual limb. So in nonprofit organization, we are inviting more and more members that are prosthesists and trying to start collaboration so that actual user can have like more comfortable hand.
But maybe you already have some ways to do it, some ideas about doing, for example, scanning residual limb or something more.
Yeah, of course we want to combine 3D scanners, but it's not exactly the shape they have because you have to take care of like how neurons are placed, because sometimes it's really hard, sometimes it's kind of dumb. So prosthesis adjust. Like some part they make it tighter to make it hold tightly, but some part they make it loose because it will there's some nerves. So those analog knowledge have to be combined, even though digital technology is coming.
Okay. If it comes to the neurological notion, which is body image, in your work, did you use some sources of this kind of research on how the body image, how this hand integrates to body image? And if yes, did you have any figures on like how quick it can be and what equipment can actually make it more efficient?
I haven't wrote like any papers, like I didn't publish in the academic field yet, but the guy Morikawa-san have tested this, and his phantom pain actually reduced. In cognitive science field, it is said that two things is important. One is sense of ownership. Another is sense of agency. So sense of ownership is like the position of the hand. You think this hand is yours. Sense of agency is the idea that you think you're actually controlling this hand. So so from that point of view, for Morikawa-san, I think he really liked this hand. So even though it looks not natural, like skin color, but he have some sort of ownership on this hand, and also he can control it as he thinks. So that's I guess the reason why it reduced. But at the same time, Morikawa-san became so famous in Japan after we collaborated, and he even asked to use other hands too. But then it turned out that his phantom pain gets worse because he's changing the hand every day, so he doesn't know which hand he owns and which hand is the hand he actually controls. Each model have different difference in terms of delay, a certain slight difference, but it's huge for cognition. So there's some side effects like that. So yeah.
And on what level do you think it's actually possible to control? On the level of electronics or on the level of mechanics? And how do you think this time gap between like recognition, this part is your own body, like how quick and when it can be like made the smallest?
Well, I'm not a profession in cognitive science, so I cannot state anything. But well, I want to have more test users in our community in Japan to see what will happen to like people. If I have like more samples, I probably can find some rules there. But like I don't know yet what is the most important part for.
Okay, thank you. And the last question, will I be able to try it on after? Can I try it on after?
Oh, yeah, please.
Awesome.
Yeah,
Thank
everybody, please try it.
Yeah, I would love to ask about the form of the hand, because it doesn't look like a human hand because there's no skin-like cover, but yet you decided to stick to the form of human hand, 5 fingers and proportions. And I was wondering if you were thinking about changing the shape to more like robotic grips to make it more functional and easier to maybe produce or use, for example, for kids and to start working with prosthetics?
Well, from aesthetic viewpoint, I think 5 finger is the most natural way people recognize hand. So I also designed this with 5 fingered. But like the movie I showed in the last, the TRS prosthetics. So for like some sports use case, the hand could be just a net for playing hockey, or like the attachment to the pipe when they play canoe or like things like that. So I don't know. It could be the good part of prosthetic is you can change easily. So I guess the more we provide the choices, I guess the more they like it. I know.
And one more question: what is the final cost of the prosthesis?
The cost?
Mm-hmm.
Well, we're not selling this at the moment, but we have open source data, and if you want to make by yourself, I guess you can make this within $500, including 3D printing and all the electronic components.
I'd just like to add that the idea is pretty simple. We need to extract some signals from the body. It may come from the muscles, from the brain. Everything's possible. So the technology is rushing to get these signals. If we'd like to move the hand freely, we would need not only one signal, like we use in this case, but we would need at least 5 signals, but the fingers move this way as well. It means 2 more signals. This is the tricky part. So we would have to get from somewhere like 10, 15 signals, separate signals, clear signals, easy to read, easy to translate, and easy to bring back to the mechanical device that is able to do it. This is the tricky part, to copy the hand. So at the moment, what this hand does, it reads one signal and transforms it in some sort of grasp with the help of other buttons, etc. And if we stick to the muscles, we got a lot of muscles right here. We can read them. We already developed a system when 8 muscles around the forearm can read something, and we can predict that that person was doing such a move, or this one, or like that. And based on that, we can transform it and make other fingers moving or whatever we like. But still, this is pretty complicated. And if it goes to the brain signals like EEG, or it's getting very, very tricky. This is a very noisy signal, like you would open some song in a sound editor. It looks like this, and you have to extract like 7 signals from that one. This is hard. The approach is to use machine learning or some neuron networks to extract that, but still this is tricky. And if you ask when that's going to happen, I think it will, but it's pretty, we need to ask Google where are they going and heading, because they have the technology that is the closest one to get that type of computation that is needed. But the approach could be creative. I mean, we can use chest muscles. We could use the brain is great. It can learn a lot. I mean, we could control it by our legs. Anything like visual system or blinking, that's not a problem. We just need the signal and then transform it to some sort of mechanical movement that will give us success. And the thing about when this prosthesis is yours is, in my opinion, it has to react fast. So if I contract the muscle, it has to do something, because otherwise I think it's some kind of tool attached to me. It's not mine. It didn't react fast enough for my brain, and brain works pretty fast. So it's really, if I do something, it has to react. The other thing is it has to be fast itself. I mean, if I send the command, please grab it, it can't move like that. Some of the products do it, because it's not my hand. I would do it faster than that. So there's something to do with the mechanics of that hand. And the third thing is to send back the signal. I grasped something, and the hand sends back the signal. Yes, it's happening by vibration or something. Because when you hold something, you feel it. The sense of touch is also important part of it. The sensors in this area, pretty much is happening. I think the sense of material or that you're holding something will not be a problem. The biggest challenge is to get the signals from the body, or do what's possible, because it's about that. We won't promise that we'll do the hand itself, because it was quite a long time since we got our hand, and it's pretty optimized. But yeah, we should do what's possible and then just work on it.